Well, hi everyone. All right, we've gone through a couple of days of graphing. Everything we've graphed has had either the x-axis, y equals 0 as an asymptote, or it has had another type of horizontal asymptote. They don't all work that way. You know that we had a case when n is greater than m, we said there's no horizontal asymptote. But there are asymptotes, they're just not horizontal. Now, we are only going to focus on one case, when n is exactly 1 more than m, when n equals m plus 1. Then there is a slant asymptote, which is a linear asymptote. We'll use long division to get the equation of that slant asymptote. So let's see what we're doing here. The example we have is f of x equals 2x squared minus 5x plus 5 divided by x minus 2. Alright, I've set up the long division. I probably should have just gone with synthetic division. That would have worked too, but I've already got some long set up here. So let me just go through. If I take 2x squared divided by x, do you remember the lead term divided by lead term? That is 2x. I'm going to put my 2x right here. And 2x times x. Let's see, what was... we divided, then we multiplied, then we subtracted, and then we brought down. Just trying to remember the steps there. 2x times x is 2x squared. Negative 2 times 2x is negative 4x. We subtract that. That cancels. Negative 5 minus negative 4. That's negative 1x plus 5. And then I'll divide negative x by x and get negative 1. So I'm going to put a minus 1 there. And I have negative x, and negative 1 times negative 2 is positive 2. And I'm going to subtract that. I'm just making sure we're doing all right here. And 5 minus 2 is 3. This degree is bigger than this, so we're done with the dividing part. Our answer, our quotient, is 2x minus 1 plus 3 over x minus 2. So this is equivalent to this. Now, the slant asymptote equation, and I'm not going to write f of x, I'm going to just use y when we talk about the asymptote. Just, I don't know, not confuse the issue, is y equals 2x minus 1. Okay, it's the part up here before the remainder. Now my question is, why is that a slant asymptote? When we have this, okay, the horizontal asymptotes are really just limits. The vertical asymptotes are determined by the denominator. Like the vertical asymptote here is going to be 2 for this problem. But when we're talking about horizontal asymptotes or slant asymptotes, we're talking about what is kind of the end behavior. And as this function, which is the same as this function, just rewritten this way, as this function approaches infinity, as it gets really, really big, let's just say, for example, 1,000. If I take 2 times 1,000 minus 1, I get 1,999 plus 3 over 998. So we're talking about, what did I say, 1,000? 2 times 1,000 minus 1 plus 3 over 1,000 minus 2. That's 2,000. That's 1,999. And then this would be like 0.00 and then maybe like 299 or something. I don't know. I can divide that out. But this is very small. This becomes pretty unimportant. And the bigger it gets, the less important it becomes, the less influential to the outcome. The biggest part of the outcome is determined by this part here. So that's why that's a slant asymptote. The bigger x gets, the closer it just approaches the line here. And it works with negative infinity as well. This would become just real negligible, this part. This part will give you most of the answer. So, we're talking about the limit as f of x, as x goes to, limit of f of x as x goes to infinity, and the limit of f of x as x goes to negative infinity really is the part without the remainder. Okay? So, I'm just going to write equals 2x minus 1 here and equals 2x minus 1. This is f of x right here. Okay, I'm going to save the rest of this example. What I want to do is just make the whole graph now, but I'm going to do that on the next video.